All right, boys and girls, welcome back to the last section of SAT geometry. So far, I have talked about lines and angles, triangles, polygons, and last one was circles. So if you haven't checked them out, make sure you do. And now I want to conclude with 3D shapes, their volumes and surface areas. Now this topic, a lot of students actually find it pretty difficult, but the calculation part of these are pretty easy. The main part is getting your head around the 3D shapes. Once you do that, everything else becomes very easy. So again, I've divided this into 3 parts, and I'll very briefly talk about a few things, about a minute or two, and then I will jump right into solving a few problems for each of them. Okay, so let's see what we have here. We have prisms. Now prisms are 3D shape. They are basically longer version of 2D shapes. I mean taller version, let's say, because it's a 3D. Now we have triangular prism, which is again triangle, got a little taller and got out of 2D world. And we have rectangular prism, again rectangle, or cube could also be a good example of that. And we have hexagonal prism, which is again hexagon but in 3D shape. So we've got some lateral area stuff. The lateral area of a prism is the perimeter of the base times the height of the prism. So perimeter of the base times height, that could also be lateral perimeter of the base times height. Okay, yes. Total surface of the prism is the sum of lateral area and the areas of the bases. Obviously, if we have a surface, which is when we do a surface area, we have to cover everything, right? So when you have this triangular prism, you have to take into account 3 sides and 2 bases, so 5 sides in total. The volume of the prism is equal to area of the base times the height of the prism. Base times height is usually the formula for everything, right? So if for triangle, it will be, 1/2 of base times height divided by h. For rectangular prism, it will be ABH, AB being the sides of the rectangle, and etc. Now, there's a cube. Cube is a special type of prism. It's basically a rectangular prism, but every side of it is equal, meaning length, width, and height. The volume of the cube is equal to, but the formula doesn't change actually. Volume of the cube is equal to area of the base, which is s squared, times h, which is s. That becomes s cubed, and the surface area is 6s squared, which, because cube has 6 sides, we just add up the sides, have more space. The figure above shows a cement block of 36 by 20 by 9 with 2 10 by 8 openings. What is the weight of the cement block to the nearest gram? Now again, the image seems complicated, the wording seems complicated, but it's a very simple question. So we have a cement block. Now, if we didn't have these holes, these are holes, so somebody imagine you took out a piece. The total volume of this would be equal to area of the base times height, right? Scroll up. Volume, base times height. So, what is our base? Our base is equal to 36 times 20, and the height is 9. So whatever this is, that's going to be our height. I could calculate that potentially and tell you the answer. So that's going to be 36 times 20 times 9, 6480. 6480. So that's going to be volume of the total. Now we don't have the total, we have 2 pieces missing. So what are those 2 pieces? They're equal to each other. We can see from the measurements that we have, 10 by 8. That's the rectangle part, the base and the top, but the height is still the same with the cement block, which is 9. So area of one of them is going to be, volume of one of them is going to be 10 times 8 times 9, which is 720, right? 2 of them will be 2V, so 2 times 720. Now, what do we need? What is the weight of the cement block to the nearest gram? So this is V total. I'm going to call this V small, 2V small. So V total minus 2v small is what we're looking for. 6,480 because of 2 times v small. So that's going to be 0, 4, 0, and 5. So 5,040. The answer is going to be A. That is, that's a volume. So that's gram over. The figure above shows aluminum block of 10, 8 by 12. What is, with an 8, 6, 12 in opening, what is the weight of the aluminum block to the nearest pound? Now that's again basically the same question. So the volume of the total is going to be equal to 12 times 10 times 8, which is equal to, I want to say 96, hopefully it's correct. And the opening, V opening, has same height, so 12 times 6 times 8. Where did I get that? I get that from here. Okay, so that's going to be, I don't know what that's going to be actually. I need to calculate that real quick. So I know 72 times 8, 576. 576. What is the weight of the aluminum block to the nearest pound? Okay, so the density of the aluminum is this much. Okay, so the V remaining is going to be 960 minus 576, and that's going to be 15 times 7, 8. 8 times 8 minus 5, 3. 384. But that's volume. That's volume. So to find the 384, multiply 0.098. To find the mass, because we're looking for weight, weight is going to be equal to volume R times the density, 0.098. That's going to be 384 times 0.098, and that's going to be, let's see, 37.6. We don't have 37.6, but what do we have? We have 38. So that is the nearest one. All right. Now, we're going to look into cylinders and spheres. A cylinder is a very interesting and very simple figure. It's just a circle that again has a 3D shape. So whenever you open the cylinder up, that becomes a rectangle. Well, the sides become rectangles, so you can think of this as a cylinder, right? And there's top and the bottom, which I don't have them. But if you open the sides, so imagine this is your cylinder, if you open it up, it becomes a triangle. Sorry, not triangle, a rectangle. Okay, so that's basically what these notes are about. So the lateral area of the cylinder is 2 pi r times height. Where is that coming from? When you open this paper, your circumference becomes your length of the rectangle, and the height is your what? Height is your side of the rectangle. So the lateral area will become 2 pi r h. Total surface area is again surface area of the rectangle, which is 2 pi r h plus 2 pi r square. Why 2 pi r square? Because the bottom is the square. Bottom is the circle and the top is the circle. Bottom and top is the circle. So that means pi r square each. That's 2 pi r square. And the volume is again the same. Area of the base times height, which is pi r square times height. Let's look at the spheres here. Sphere has a volume of 4 pi r square and, surface area of 4 pi r square and 4 over 3 pi r cube as volume. In the figure above, a sphere is inscribed in a cylinder so that the diameter of the sphere is the same as the diameter of a cylinder and the height of the cylinder. What is the value of volume of sphere divided by volume of cylinder? So from this image and description, we understand that this ball, sphere, is inside the cylinder and it's touching everything, meaning it touches the side, it touches the top and the bottom. So if the sphere has a radius of r, the cylinder will also have a radius r, and the diameter of a cylinder, meaning the top and the bottom, or any, doesn't matter, but we need the top and the bottom, it's going to be 2r, which is also going to be our height for the cylinder, right? So the volume of sphere is going to be equal to 4 over 3 pi r cube. We talked about that one. So if you go back a few seconds, you'll see the volume is 4 over 3 pi r cube. And we need the volume of the cylinder, which is equal to pi r square h. But we also know what height is. Height is just 2r. So pi r square times 2r, which we can write it as 2 pi r cube. Now we need to find what? V of sphere, volume of the sphere, volume of cylinder. That's going to be 4 over 3 pi r cube and 2 pi r cube. So pi r cubes will cancel out. We're going to left with, so 4 and 2 will cancel out. We're going to left with 2 over 3. So the answer is going to be B. The figure above shows the mechanical part in the shape of steel cylinder, 8 inches high and 6 inches long in diameter. A hole in a diameter is 3 inches is drilled through the mechanical part. The density of the steel is 490. What is the mass of mechanical part to the nearest pound? We know that there is a cylinder, but piece of it is gone. Again, you can think of a cylinder like that, but a bit thicker walls. A bit thicker walls, not paper thin, actually thick wall. And there's a hole in the middle. So we're going to find the volume of the big sphere if it was full, and we're going to subtract the small one from it. So we're going to find the volume stuff first, and then we're going to calculate the weight stuff. Okay, because they're asking us for weight. So let's see. Volume of the big sphere, I'll call it S1. Sorry, not sphere, cylinder. C1 is going to be equal to pi r square h. Now pi will stay. R square, what is r? So 6 is the diameter, meaning 3 will be the radius. So 3 square is 9 times height is 8. So that's my volume for the large cylinder. The small one, C2, is going to be equal to, again, pi r square h. H is still the same. Pi is still the same. The radius is, the diameter is 3. Half of that will be 1.5. So 1.5 square is 2.25. Okay, so to find the volume remaining, we need to take 9 times 8, actually just 72 pi. 72 pi minus whatever this is, 8 times 225 is going to be 18 pi, and that's going to be 72 minus 18 is going to be 54 pi. 54 pi. 54 pi. So what is 54 pi? That is our remaining volume. Okay, now 1 foot is 12 inches. Okay. Now, this has inch cube. Let's move it down here. The metric for this one is inch cube, right? So, 1 feet is 12 inches. 1 feet is 12 inches based on what they gave us. That means 1 foot is 12 inches. So, 1 foot cube is going to be 12-inch cube. And that's going to be, what is 12 times 12 times 12? 1728 cubic inch. Okay, now, how is that useful? So to find the mass of mechanical part, we need to find density times volume. Now, we see that density is given in the question. It's 490. Okay, and the volume is going to be 54 pi, but we did this conversion here, so 1 over 1728, okay, and whatever that number is, let me see, 48.1. 48.1 pounds. So the closest answer is C, 48 pounds. All right, last thing we're going to look at is pyramids. Pyramids are a bit more complicated in terms of their shape and what type of questions you can get from them. But there's usually something to do with the height that you have to drop from the top. And there could be some triangles created, and you can use the slant, which is this line here. Actually, you can see what slant is. The line that goes from top to the middle of the side, if it's equilateral, assuming. So it's a lateral face, a line in the lateral face, but it drops to a 90 degree. So slant is very important to know. To find the length of the slant, you create a little triangle like this one here. So height will be one side of the triangle. The slant will be the hypotenuse, and then half of the base will be your, I'm talking about the rectangular pyramid here, but the idea is the same. So base, height is the height of the pyramid, and slant is going to be your hypotenuse. So we have some stuff here: lateral area, surface area, volume. We'll use that in a bit. Again, lateral, there's also cone here. Cone is more interesting, well, not more interesting, but another interesting shape. Again, lateral area, surface area, and volume. So there's no point of memorizing them. So let's solve some problems. The figure above shows a pyramid with a regular hexagonal base. The length of each side of the hexagonal face is 4 units, and the height is 7. What is the volume of the pyramid? So the volume of the pyramid is 1 over 3 area of the base times height. But we don't know what the area of the base is. But here's a fun fact. I'd like to explain it this way. So regular hexagon, when all sides are equal, consists of, let me make it. So imagine this, this, and this. So it consists of 6 equilateral triangles. And all of them is going to have 4 as their side. So 4, 4, 4. Okay. Now, if you have an equilateral triangle with 4, 4, and 4, the area of that is going to be 4 square root of 3. This is known, but you can also drop a height. This is 2. This is going to be 2 square root of 3. Do base times height, you'll still get to the same answer. So one of the triangles has 4 square root of 3. That means 6 of them. So the base is going to be 6 times a, which is going to be 24 square root of 3. So that's base. Height is given 7. So we can say volume is equal to 1 over 3 times 24 square root of 3 times 7. We can cancel them out. 8. So it's going to be 56 square root of 3. So the answer is going to be, all right, last question of this video is going to be about cone. Water is pouring into a conical reservoir at the rate of 2.4 meter cube per minute. If the radius of the base of the conical reservoir is 9 meters and the length of the lateral edge is 15 to the nearest minute, how long will it take to fill up the empty reservoir? Okay, now, since we're talking about filling it up, I'm guessing this is more of a volume question, but let's see. What do we know? We don't know the height. We know the lateral edge is 15 and the radius is 9, which means we can find the height. That would be a good place to start. So if you think of this as a BC triangle, then AC is a hypotenuse, meaning 15 square should be equal to height square plus 9 square. So height square is going to be 225 minus 81, and I believe that's 144. and h is going to be equal to 12. So we found the height. Now let's see what the volume of the cone is. The volume of the cone has a formula of 1/3 pi r square h. We have all the details, I think. Let me move it up a little so we can see. 1/3 pi times 144 rather, times, no, not 144, height is 12. R is 9, so this is 81 times 12. Okay, 81 and 3 can go. This is 27. 27 times 12, whatever that is, 324 pi. Now this is volume. Okay, but we're not done. We're not done because it says it's per minute we're filling out 2.4 cube meters. So we need to know how long will it take. So to find the time, we need to divide the volume by rate. So 2.4. This is going to be 324 pi divided by 2.4, and that's going to be, according to my notes, 424.1. 420.1, so C is the correct answer here. Okay, so that was the last video of geometry part of SAT review classes. Hopefully you guys enjoyed it, but most importantly, hopefully you learned something. Now again, the volume and the surface area questions can get complicated, mostly because of how difficult it might be to visualize it for some people, but the ideas are quite simple. Usually the right angle triangle can come handy in many of them, but other than that, the area of circles, area of rectangle are basically the essence of 3D shapes. All right? So thank you for tuning in, and I will see you guys day 4 or day 5. Anyways, I'll see you guys in the next video. We're going to go back to doing more algebra and advanced math. Okay? See you later. If you have any questions, do let me know. Have a good one.